Okay, welcome back. This is part 4 of lesson 6.1. So now we're going to do something a little different. We're going to look at using these geometric sequences. What if we don't know the ratio? And we want to try to actually find the ratio for a geometric sequence. So for example, this example says the shutter speed settings on a camera form a geometric sequence where A of n is the shutter speed in seconds and n is the setting number. The fifth setting on the camera is 1/60th of a second, and the seventh setting on the camera is 1/15th of a second. We want to find out, what are those ratios? What would be the, first term in the sequence? Write an explicit rule. All of these things. So we're going to do multiple things here. So identify the given terms in the sequence. So here are some things we do know. We know that f of 5 is equal to 1/60th. We also know that f of 7 is equal to 1/15th. So we can see that as we go up in settings, the shutter speed gets slower. So that kind of tells us if we were to go down in settings, the shutter speed would be faster. It would be a larger fraction. So now we want to find the common ratio. Okay. This is not always the easiest thing to do, but we can do a variety of things to help us with this. One thing I'm going to do is I'm going to make a quick little table here with the settings. 0, 1, 2, 3, 4, 5, 6, 7. Again, we know that it's position 7, it's 1/15th. Position 5, it's 1/60th. And so we have to think about, what is this, what is this thing doing in between these settings? So we're going to go over here, and we're going to look at some ways to solve this, kind of working backwards. And here's one way we can work backwards. We know that when we have 1/60th, that is equal to A of 1, we're not sure what that A of 1 is, times R, that's our ratio, to the 5th power. Okay? So we know that. Now we can rearrange this to show that 1/60th divided by R to the 5th power is equal to A of 1. Okay? So that's something that we know. We also know that 1/15th is equal to A of 1 times R to the 7th power. Now what we can do here, we've rearranged this first equation to put it in terms of A of 1. So A of 1 is equal to 1/60th divided by R to the 5th. We can now substitute that in here, A to the 1st, which will look like this. 1/15th is going to be equal to 1/60 divided by R to the 5th outside times R to the 7th. And this is going to help us to find that ratio because we've gotten rid of the A to the 1. It's not there anymore. And we can get down to just solving for what that ratio is. So if we're going to do that, we can do some simplifying. 1/15th is going to equal 1/60 R to the 5th, just times R to the 7th, which this R to the 5th is going to cancel out. This is where exponents come in handy. And this is going to turn into R squared. So that means 1/15th equals 1/60th times R squared. I can divide both sides by 1/60th. So I'm going to divide 1/15th by 1/60th. That's going to give me 4. 4 equals r squared, and therefore r is equal to 2. And now if we were to go back here, we would be able to see that it is changing. It is being cut in half each time, or it's doubling, I should say, every time we go up in a setting. So, for example, if I'm at 1/15th and I go to position 6, it's going to be at 1/30th, 1/60th. This would be 1/120th. So, find the common ratio. That common ratio is 2. Let's continue over to the next side where we can finish the problem up. Find the first term of the sequence. If I want to find that first term of the sequence, all I have to do is just keep going backwards, keep doubling it each and every time, and when I get to that f of 1, it's going to equal 1 over 960. So the explicit rule here would be f of n is equal to 1 over 960 times 2 to the n minus 1 power. And now you could use this, you could put in any number, like for example, if we were to put in, 5 back in here, that would give us that 1/60th, that first setting, okay? All right, so let's look at one last problem, where again we're going to be trying to find the ratio. So it says you tell a number of friends about an interesting video you saw online. Each of those friends tells the same number of friends about it. This pattern continues and there are no repeats in the people told. The numbers of people who hear about this, about his video through you from a geometric sequence. There are 256 people at the 4th round and 4,096 people at the 6th round. Identify the given terms of the sequence. Well, first, we know this. We know that when x is equal to 4, y is going to be 256. And we also know that when x is equal to 6, y is going to be equal to 4,096. So now again, we want to find that common ratio. So we know, just like we did before, we have 4,096. That would be equal to 1 times r to the 6th. And again, we can do some rearranging if we would like. We also know that 256 is going to equal a of 1 times r to the 4th. So that's the 4th position. So we can rearrange either one of these and substitute it into the other one if we would like. I'm gonna rearrange this one. So we know that a of 1 is going to be equal to 256 divided by r to the 4th. And so now I can plug that in. 4,096 is equal to 256 over r to the 4th times r to the 6th. And those are going to do, we're going to do some canceling there. So that r to the 4th is going to cancel out, and this is going to leave us with r squared. So we've got 4,096 is equal to 256 r squared. Divide both sides by 256. That gives us, so 4,096 divided by 256 is 16. That is equal to r squared. So r is equal to 4. So the common ratio here is 4. And we want to find the first term in the sequence. So again, we know that each time it's being multiplied by 4. So we can backtrack and divide by 4, divide by 4, divide by 4. So the first term is going to be 4. So then our explicit rule is going to be f of n is equal to 4 times 4. That's it. So 4 is our first term, but 4 is also our ratio. And to the n minus 1 power. And that gives us our geometric sequence.